Thank you for joining us today at the ProQuality conference. My name is Alena and I'll be your host. Also, please say hi to our tech moderator Alexei, who will be responsible for our tech stack throughout the session. And today we're starting with a talk about testing, of course, but to say specifically, we'll reflect on the importance of testing through a not so typical example, transport simulation, which basically means testing potential traffic flows. And I'm very delighted to see Nadežda as our speaker, a professional with huge experience in both topics, testing and transport simulation. Nadežda, hi, it's so great to have you here on the ProQuality conference.
Hi, thank you for having me.
The pleasure is ours. And dear audience, before we start, please let me comment and invite you to ask any questions you would have throughout the presentation by our YouTube chat, and we'll address them at the end of the talk in the Q&A session part. And please also keep in mind that you can rate our event and send a badge to our speaker on the VIA community platform. So, Nadežda, what an unusual analogy. Why exactly transport simulation as example?
Because it's something that we all experience. Every day we take part in a transport system, like drivers, pedestrians, cyclists, even maybe even as public transportation users. And it's something that we can all relate to. And if we look honestly, we all think it's something we also know how should work. And for me, like personally, when I'm driving, I'm get annoyed at pedestrians. When I am walking, I am frustrated with the cars. But when I have had of transport planner and simulator, I actually need to see all this perspective and balance these competing needs. And I think exactly this complexity is something that great and makes this a great analogy for software testing.
I'm eager to hear.
Great, and I will continue from here then. And today I want to share a story from two different worlds, from transport simulation and software testing. And maybe they seem unrelated on the first glance, but they actually have a lot of common, and I hope that you will see it through my talk, especially when it's come to testing. And so I actually started my career as in urban traffic simulation, and then I over the time transitioned it to software and quality assurance, automation, and quality leaderships. And what fascinates me is how in transport simulation, testing is never questioned. It is simply essential part of every project, and it's just part of the project. But in software development, when I moved to QA, and still like conversation is going very different. We still continue to debate whether testing is needed, who should do it, and when. So today I just wanted to share and explore this contrast. Quick overview of what I'm covering today. First, just short explanation what is what I mean when I talk about transport simulation and software testing, just to be on the same page. Then I will looking on how testing works in simulation and a quick comparison to software testing, highlight some parallels and similarities between these two fields, and finally, hopefully, some takeaways about building trust through testing. But before I'm going to details, I'm just curious because I understand maybe not so often topic traffic simulation. So what comes to your mind when you hear the term traffic simulation? So please take your phones and go to menti.com, enter the code you see on the screen, and you also can use QR code and just answer something what first comes to your mind when you hear traffic simulation. And I will continue, and I will be back to this, so please answer it. And yes, so maybe I will I will continue. So what this transport simulations means, it actually uses mathematical models to imitate driver behavior, traffic flow dynamics, and how the overall system, how it's overall works in response. And transport simulation is a tool that can be used by city, by transport planners, transport engineers, to make informed decisions about actually how we live, regarding, of course, transport, about road, about traffic infrastructure, public transportation, some temporary constructions on transport. And it usually helps answer critical questions like, what if? What if we build new bridge? If they will be congested, under congested, where are the bottlenecks? What happens if we close the road? Or if what happens if we will new bridge will be built, and does it will help or not? And simulation models allows us to answer these questions and evaluate complex transport strategies, identify network bottlenecks, and test solutions before implementing them in a real world. So in short, we simulate before we build and construct, because in transport simulation, mistakes cost millions and affect thousands of people. And I really think that everyone can experience what this bad transport infrastructure means in daily life. And the transport simulation operates on different levels. So macro level models looks at entire cities, and they help us understand the big pictures, how people move across the city through the day. Or, for example, if we build a new bridge, how vehicle strips will be distributed through the city. Then we have micro level models. It's zoom in on individual intersections. And actually now on the right side, you can see example of micro simulation models, visual representation of 3D. And these micro models helps us analyze how traffic behaves at the level of specific vehicle or driver. So we can zoom in and see what happened on specific intersection, on specific line, on specific public transport stop. And then the meso level, something in between macro and micro, that focus on corridors and districts, and is useful for evaluating traffic patterns in more detail, like city center or maybe some area along the major route. And each level support different types of decision, from broad policy choices to street level changes. And to sum up, so simulation help us design transport systems by testing ideas and solution in a safe, controlled environment before they are built in real world. And of course, it's a simulation is always cheaper, faster, and safer way to test. And now let's shift to software testing. Oh, there are so many definitions, and approaches and expectations, and often differing from team to team. Please do not try to read the picture. It's just for illustration purposes. Because it's something that I received this list at my very first testing workshops a long time ago for now. And honestly, it was overwhelming. Like I look on it and okay, so where do I even start? And there are many ideas and discussions about what testing is, and just as many about what it isn't. So, just for today, to be clear, when I talk about software testing, I mean the definition by Michael Bolton and James Bach, which describes testing as a process of learning, exploring, and understanding. And that actually fit perfectly with how we approach transportation model testing in transport simulation. In both fields, testing is really investigation and a way to uncover risk, build confidence, and ask better questions while navigating through uncertainty. And switching back to transport simulation. So here is what a typical transport simulation development workflow looks like. So we define the problem and objectives, build the model, including programming and testing. And here, testing goes under three words: verification, validation, and calibration. Then develop scenarios, evaluate solutions. And this is full development cycle of transport simulation model, and the testing is just one of the steps. And it's actually quite similar to the software development lifecycle, where we follow, I would say, similar, we can see quite similarity. So we plan, we got the requirements, we design, code, test, deploy, and maintain. So two very different fields, yet the development steps are surprisingly similar. Now, let's look at what they share in common. And the first and one of the important, at the core, they both rely on models. In traffic simulation, we model vehicles, pedestrians, traffic infrastructure, traffic light, public transportation. In software, we model user actions, data flows, and system interactions. And these are not real world environments. They are structured representation designed to help us understand and improve system. And transport engineers begins by collecting real world data. So we need different counts, vehicle, pedestrians, cyclists, micromobility, signal timing, line geometry. And software tester does the same. So analyzing requirements and understanding how real users will interact with the product. Then comes to testings and scenarios. So in transport modeling, we push traffic models through rush hours peaks. It may be morning peak hour, evening peak hour, weekday, weekend, road closures, rear detours. In software, we run functional tests, non-functional, different kind of test cases, load testing, security, explore edge cases. And the goal for both is the same. So find weaknesses before they hit the real world, whether that is in production or on streets. Next, validation follows. In transport, we compare simulator behavior with observed. In software, we compare actual output with expected results. And any differences shows us that something important is either missing or misunderstood. And finally, we iterate. Traffic modelers tweak driver behavior, signal offsets, demand levels until model match reality. And developers refactor code, fix defects, until all tests pass and software behaves reliably. So whether you're working with software or calibrating a citywide traffic model, the process is the same. We analyze, simulate, validate, refine. Different domains, but identical mindsets. And then comes the question. So then why testing in transport simulation never negotiable? It's just a must. So what's happening? And in transport modeling, if we do not trust the model, we actually cannot trust the output. And testing here is not optional. It's what gives credibility to every future decision. Every scenario we simulate relies on how accurate today's model is. And if the model is wrong, the consequences are real. So poor infrastructure, wasted investments, and unhappy communities. And communities, it's me, it's you, it's everyone of us. And the validation in transport simulation, it's not just about checking how system works. It's also about making better informed decisions. And in some cases, it just can affect whether you gain or lose a client. So on the right, you see an example of transport simulation model from real project from some time ago already. But it's an example of poor validation. And it was just a visual bug. Cars looping unnecessarily before continuing their route. But clients saw it that and lost trust in results because again, all in transport simulation, like all result is mathematic and calculations, and visualization. It's just for more clear understanding. So we asked to redo the entire simulations when client get such result of work. And we redo it, but in the end, all the numbers were correct. And the issue was simply that model wasn't fully tested before delivery. So test before delivery. And how it works, so this testing in transport simulation. And it begins with verification. So are the input and logic correct? Then follows validation. Does the model match reality? And calibration. Can we fine-tune the model to reflect real-world conditions? And these steps gives us confidence that model is usable and trustworthy. And now let's look on software side. So we're switching again. And here I experienced and heard a lot like we are quality first approach. And then you like hit reality. And I'm sure you can recognize at least one of these situations, and you already, I think, experience even maybe more. So feel free to share in a chat what is the most common excuse you have experienced when testing gets cuts and or delayed. One of mine on the first place is we will fix it later, so which often means never. Or there are other priorities right now. Let's wait and see if users complain, and if and when we will see do we need to fix or no. Automation, yes, sure, very important. We need it, but not today. Delivery is tomorrow. So do whatever you want and can, but delivery is tomorrow. Depth improvements, maybe next sprint. And it's not because people do not care. And it's because testing still feels optional, like it's nice to have instead of must to have. And so then why? What is this difference between transport simulation and software testing? And one of these differences, I would say, is the weight we place on testing. In transport simulation, we rely, yes, on verification, validation, calibration, the way humans rely on a load-bearing lag. And if that lag fails, the model collapses, results becomes unstable, and you cannot stand. You don't have this balance to continue. And in software development, in testing, we also rely on different levels, but testings, at least for me, looks like more manipulative arm. Losing arm is painful, maintainability, velocity, confidence suffer, but system still can like stand and deliver value. And quite often we actually use it. And another example I would say is model difference on model validity and how we look on it. And in the center of Riga, near the central station, the new office building. It's just on the left side of the picture, is just pictures from Google map. And what interesting that we worked on traffic impact study for this site all the way back in 2006, so already 19 years ago. And I remember it well because, you know, it's actually something was my first ever traffic impact study. And now, 19 years later, after all financial crises, COVID, many delays and changes, this development finally completed. And it's mean that all these assumptions, all these changes that we plan and model, we now actually can check and see how it works and compare the real world outcome with the original model. And I think this is something very critical. This is important on how critical these early modeling assumptions and decisions really are. And this is something you take responsibility that your decisions can have long-term impact. And it's again, you start to think differently about what you are doing. And the third one, I would say that another key difference, it's how we look on testing. In transport simulation, testing is never end goal, never. The focus is always on outcome, like who benefit from the solutions. Do we right now focus on pedestrians? Do we focus on accessibility? Do we want to improve mobility? Do we want to improve public transportation? Does it make streets safer, more efficient, more mobile, more accessible? And it's always you keep in this end value in mind. And testing is critical, but it's always in service of something greater. And now, compared to software development, somewhere along the way, we started treasuring testing like the goal itself. We're talking a lot about tools, layers, automation frameworks, and it's great, and we need it. But we lose sight of why we are testing and who we are testing for. And to sum up, so in transport simulation, testing is not negotiable, and not because of processes, but because of consequences. And if model is wrong, people pay the price in time, money, and safety. And this is why nobody ever questions whether we test, only how well we do it. And in software, we often treat testing as optional because we believe we can test, we can fix it later. But like in a simulation, if we skip testing, we are not saving time. We're actually planting uncertainty. And when you test truthfully, we actually build trust in the models, in the software, and in the people behind it. And of course, testing help us make better, more confident, more informed decisions with less risk and better outcomes. And if our assumptions are wrong, then everything that we build on top of them will be wrong too. So let's start asking, what kind of future are we building, and can we trust it? Okay, thank you very much. And now I'm...
Okay, thank you. Thank you, Nadežda. And that was really an interesting presentation and an unusual view on this topic. I would say quite insightful. And I bet we already have some questions in our chat. But before we continue, let me remind, dear audience, if you haven't sent us your questions yet, that's a sign to do that right now. And if you enjoyed the talk, please scan the QR code you see on the screen to rate our event and give Nadežda a badge. So let's start the Q&A session and see what we have from Aka. Great. Nadežda, thank you for your talk. Could you please elaborate on how you got into the field of transport simulation? It's so unusual and very interesting to hear.
Actually, by accident, how it happened. So I was in my master degree and was thinking like, what will be my master work, and I decided. So I was not sure what I want, and then actually one of professors like. I get connected with a company who work with traffic simulation, and I started writing my master degree and then just continue working with that. Yeah, but just by accident.
Well, they say that probably one of the greatest things in life happened by accident, and I can partly agree with that. So thank you for the story. Okay, let's see what we have else. In real life, we often come across the situation when we have to build an optimal test suite adapting to changing environment. Is it ever an option for transport simulation? I believe it's ever changing test suite and modifying from each release to each release. Yeah.
Yeah, sure, because actually also in transport simulation, we face a lot of changes because like new infrastructure plans, they come all the time. Traffic regulations, policies, everything is like changes quite fast. And also it's like new data sources come in because technology also evolving. And there are also like behavior shift, what we can actually observe after COVID. So yes, we all the time actually trying to get this test suite running. And because for us, it's important that to maintain model credibility over the time, even as environment evolves. So yeah.
Yeah, and I believe even simple changes like building a new shop or even a business center near will also change a lot the whole model.
Definitely. Yes, but it's always is a questions like you should be like aware of this test suite number. I'm not sharing here as a part of presentation, but actually also when I started my career, I have an experience when I had like more than 100 different scenarios for one project, because I just wanted to make the best of the best, but in the end it was like because it's not like only visualization but all mathematics behind. Yes, and like in the end I personally somehow could differentiate, yes, all this scenario, but I was unable to share this like to a client and say which of one is better, because there was just too much. So it should be aware of this number of scenarios too.
Yeah, interesting example. Thank you, Nadežda. Okay, one more question. What traditional testing techniques can be applied in transport simulation?
The first ever is its explanatory testing, because you do it a lot. It's a lot about load testing also, so you just can use them and do it. Because you need to, for example, to check this model under different conditions. Because like you observe normal situation, I don't know, there is congestions, and for example, for vehicle to pass intersections, it's take approximately 10 minutes. Okay, you have model, it is, and then you actually need to test what happens if this like only 1 minute, or what happening if it's like 1 hour. So how system in general behave if it changes. So so a lot of that can be actually straightforward used.
I believe there are quite a lot of approaches in common and techniques because, well, the idea is the same, to test like our vision. Okay, great. Let's see. Another question. Hi, thank you for very interesting presentation. What do you think about test-driven development? Like writing tests first and developing solution that fits the tests?
I actually personally fan of it. Maybe not very fun, going specific algorithm of how to do it, but I am actually that you specifically firstly write what you want to get in result, and then you get it. Because in simulation, actually, I'm doing the same. Yes, you firstly write what you want, and then you see how it works or not. Because when you like working a lot of with simulation model and you're going in details, you sometimes lost focus, and this test driven just help you take this focus and bring it. And the same in software development. So
Well, as they say, you can get somewhere when you know where you want to get. Otherwise, you can drive as long as you want, but it doesn't bring you anywhere if you don't know where you're going. Yeah, great. And looks like that's it for the questions as of now. And we are ready to wrap up, at least for today. So, Nadežda, please let me thank you again for sharing your fresh view on the value of software testing today with us. That's really interesting analogy, and I'll remember and keep it in mind for the future. And dear listeners, and thank you for supporting this event. If you enjoyed the talk, please scan this QR code to rate our event and give Nadežda a badge. And let me also note that presentation deck will be uploaded tomorrow on our VR community platform talk page. And the video of the video recording will be available within 1 month after the conference ends, right? So right now, I would like to invite you to our next talk today, which will be happening like in a couple of minutes. We'll explore application of AI agents to the automation process. And stay tuned. Join ProQuality community in our social networks, and may your tests always be flawless. And bye. Have a nice day.
Thank you. Bye.